Dexter Hadley, UCSF School of Medicine. Translating big data into precision screening and diagnosis of melanoma with smartphones.
Hi. I'm going to tell you today about a problem where patients are continuing to die because skin cancer diagnosis lacks precision. Melanoma is the deadliest skin cancer, and early and accurate diagnosis by biopsy is known to improve outcomes. So the mainstay of treatment for melanoma is aggressive and excisional biopsy, which leads to a growing problem of overbiopsy of insignificant clinical lesions. So what we see on this chart here is that while the incidence of melanoma is increasing, there is no compensatory decrease in the death rate for melanoma because we are essentially wasting money going after clinically insignificant disease. Let's see. Okay. And the reason for that is that clinicians have no real objective way to screen for melanoma. Evidence is that 30 biopsies are required for every one melanoma that is found on pathology. Pathology remains the gold standard for melanoma diagnosis, yet out of every 7 out of 10 pathologists might disagree on what melanoma is under the actual microscope. So clearly there's no convenient and certainly no accurate method to diagnose melanoma clinically today. So I'm a faculty member at UCSF, and I'm very proud to tell you about SkinIQ, a company that came out of my lab that was founded really to bring clinical-grade artificial intelligence to the diagnosis and screening of melanoma. And what we provide is an iPhone app that serves as a conduit to a very large-scale clinical database of tens of thousands of images of pictures, essentially, of pigmented lesions with underlying pathology diagnosis. So we have medical students go into the dermatology clinics at UCSF and throughout the state of California to collect and to build up this database. With that database, we train state-of-the-art deep learning computer vision algorithms. So deep learning is a new type of algorithm where computers figure out, they learn by example, how to discriminate malignant from benign skin lesions. And the promise of deep learning is that over time, the accuracy improves. So we estimate that one medical student in the clinic can collect about 1,000 images. And over the 5 clinical sites throughout the state of California, we want to put about 50 medical students to collect about 50,000 medical images over the next year. Needless to say, we think this is a fantastic multi-billion-dollar marketing opportunity. The app alone can target about 420,000 providers that need to provide this precision diagnosis. But what we think is the money is not in the app, but in the ecosystem that it's going to develop around the molecular diagnostic, non-invasive molecular diagnostic to go after these diseases. I think I'll end there before I am asked to leave. Thank you.